Let's take a look at some examples of some trigonometry limits. Specifically, our two special limits. We have the limit as x goes to 0 of sine of x over x, and that goes to 1. The reason for that is because as we zoom in and look at this angle that's going to 0, this is the sine of x there. So that's the sine. And x is the measure the angle, and so that's this curve right here. So this sine x and this x basically end up being the same thing, so they are 1. And then we have cosine minus 1 over x, or this right here is 1 minus cosine x. That's this little piece right here, down here. And that's basically, it's got a little tiny piece, and as the smaller the angle gets, the smaller that gets. And so that's going to 0, and so that's kind of why that goes to 0. So that also is true if we flip this around, x over sine x is 1. And again, sometimes we'll see this as 1 minus cosine. Yeah, it's the same result. Okay? So these limits can show up in different ways. So let's see how we can apply these special limits. All right? So we want to try to make one of these look like one of those limits that we have there. All right? Well, here, this is not x, it's 5x. Okay? We've got to be careful. We can't cancel these. Don't cancel those. Don't try to do any of that. This is inside the sign right there. But what we could do is we could do some substitution. We could say that, maybe we say that u is 5x. And as x goes to 0, u is going to go to 0, right? As this thing goes to 0, u is going to go to 0. So we're kind of swapping this out. And we'll say this whole thing in the parentheses there is u. Okay? So we're doing a little substitution. And here we can see that this sign is going to 0, and that's in the form we had up above. And so that is 1, because we have matching variables here. All right? Well, how about this? So here we have a sum. Oh, we got sine x over there, but remember this x divides both. So we've got to be careful here. This is equal to the limit as x goes to 0 of x over x. This x divides both of these, plus sine x over x. Okay, put that in parentheses. And we've learned that the limit of a sum is the sum of the limits. All right, so we can take the limit of the first part as x goes to 0 of x over x, but that's just 1. And the limit of sine x over x. So we can take the limit of these separately. Well, the limit of the first one is 1, and we just learned that this second one here, this limit here, is going to 1. So it's 1 plus 1, which is 2. All right. How about 0 over tangent x? Well, this is the limit as x goes to 0 of x over, now tangent is sine x over cosine x. Okay, and so we just need to clean this up a little bit here. We could multiply this by the cosine of x on top and bottom, multiply by the common denominator, cosine x, cosine x. Okay, that cancels these out here. And so this is equal to the limit as x goes to 0 of x cosine x all over sine x. Well, what is that all about? We're looking to try to find this x and sine x together. Now this is multiplication here, not addition. Since it's multiplication, we could write this as x over sine x times cosine, which I guess I'm just going back to what we had up here, huh? Anyways, there you have it. Okay, this is all in the limit. And so this is equal to the limit as x goes to 0 of x over sine x times, that whole thing times the limit as x goes to 0 of cosine of x. Well, this is going to 1 and times, and this, when you plug in 0, cosine of 0 is 1. 1 times 1, which is 1. Okay? So that whole thing is 1. What about some secant here? Okay. Do you remember your secant identity, or what it's worth? Isn't it 1 over cosine, I think? So we want to get this into cosine world. So limit as theta goes to 0. Secant is 1 over cosine theta. And this is theta times 1 over cosine theta. Well, we got this denominator cosine on top and bottom. We'd like to clear that off. So anytime you want to clear a denominator, try multiplying by that denominator. Be careful, this is a binomial. We got a minus here. So these parentheses are important. Okay. And so that gives us the limit as theta goes to 0. All right, we've got to distribute this thing. And we end up with cosine times 1 over cosine is just 1 minus cosine times 1 is cosine. All over, and the bottom, these two become 1, so 1 times theta all over theta. All right, and that is our special limit. Okay, so once again, I know this says cosine minus 1 up top, but this is going to be the same thing as 1 minus cosine. It's just the opposite. It's the negative, I guess. So here, this will actually be negative because you pick any number that you plug in here, and the cosine will be less than 1. Cosine's always less than 1, or equal to 1, I should say. Less than or equal to. So this is always going to be negative, but it's going to get to 0. This thing here is 1 minus cosine is going to do the same thing. So it's going to 0 also. Okay. All right, a couple more here. Oh, we got sine and cosine. Well, again, we want to rearrange things so that we see one of our special limits there. And so we have sine of 5x. We had a 5x up above there. We'd like to have a 5 here, but there isn't a 5 there. But this is a fraction, and so I can multiply by 5 on top and multiply by 5 on bottom. So this is going to be 20 times the sine of 5x all over 5x times cosine of 2x. Okay, so we want to kind of rearrange this limit as x goes to 0 of let's see. Let's rearrange. This is all multiplication here. Sine of 5x over 5x times, we still have the 20 and the cosine 2x. Okay? And that's all in the limit. Well, we're going to take the limit of both of these here. We know that this, as we proved up above, this goes to 1. And this, well, when you plug in 0, it's the sine of 2 times 0. 2 times 0 is 0. Cosine of 0 is 1. So this is 1 on the bottom. So this is 20 over 1. And that is just 20. Okay? That's how that works. One last one here. Cotangent and cosecant. Oh boy. Well, let's get it into the sines and cosine world. Limit of x goes to 0. Cotangent is, that's cosine over sine, right? Because sine is sine over tangent is sine over cosine. This is going to be cosine over sine. And it's 11x. 11x. Just take the same angle there. And then we have cosecant Well, this is 1 over sine. 1 over sine of 25x. Okay? So rearranging, this is the limit. As x goes to 0, let's just write this as multiplying by the reciprocal. So we have cosine 11x over sine 11x times sine of 25x. And if you want, over 1. Well, what's going on here? Okay, well, I wish there was a 25x under here. And I wish there was 11x above here. So let me rearrange this one more time. Okay, I'm going to play a little wishing game here, okay? Sine of 11x. Cosine, nope, sine, sorry. Sine of 25x. We'll fill in that other parts later. And then cosine 11x. Do I have all the parts? Got that cosine there. Got the sine of 25x on top and the sine of 11x on the bottom. Okay, what do I wish I had? Well, I wish I had an 11x here. Well, I can do that. Okay, I can multiply by 11x on the top as long as I multiply by 11x on the bottom, right? Okay. All right. So I'm going to put, I'm going to have an extra 11x out of there. Okay. So this guy is going over here, and this little extra one's going to tuck over there. All right. Well, I wish I had a 25x under here because that would just go to 1. Well, I can get a 25x into my expression by multiplying the bottom by 25x and the top by 25x. So this 25x I'm going to write there, but I still need this 25x, and I'll just tuck it over here. Okay? Now, why did we do that? Well, we did that because of this. Okay? So I haven't broken any fraction rules here, but I've set it up so that this is going to 1. I don't need my limit anymore. I'm going to evaluate this thing. Let's do this. Okay, this is going to 1. The limit of this is going to 1. This is over 1 if you want. When you plug in 0, plug in 0. It's not a problem. Cosine of 11 times 0, which is cosine of 0, which is 1. And then these x's here are going to cancel. And we have 25 over 11. And what is that whole thing worth? Well, that's just 25 over 11. All right. So a little tricky there, a little clever, but that's how we can kind of force the issue to get these fractions here. That's really what we want to set up, okay? Because then we can use that property that we have. All right. Well, there you have it. Hope that helps. Gives you some good examples to use. And sometimes it takes you got to be a little clever to force these identities, or these limits, I should say, that we can prove using the unit circle. All right. Great job. Thanks a lot.